There's probably not a more controversial topic in all of psychology than that of intelligence. And this whole controversy really got going around 1903, 1904 in France, when the school board in Paris uh, asked a school psychologist by the name of Alfred Binet to put together a test that would assist them in identifying students who didn't seem to be benefiting from a traditional approach to a French education. So Alfred Binet in 1904 got together with a physician by the name of Theodore Simon, and in 1905 published a test known as the Simon-Binet Intelligence Scale. And what they did was, they got their heads together and they thought, okay, starting with a young child, let's say a 3-year-old, what are some things that a typical 3-year-old ought to be able to do? And so they had items on the test like taking a shoelace and then some beads and stringing the beads on a shoelace. They would give the kid a handful of beads and a shoelace and say, string 4 beads on this shoelace for me. And, could the kid do that? And then at those early ages, also, they would show them a picture of a doll and point to the arm and say, what is this called? Could the kid identify it as an arm and so on? Uh, the further they went age-wise, the test became increasingly verbal, asking them to define different words for them, work math problems in their head, and so on. And the old Binet was a nightmare to give as a psychologist. You had to establish what's known as a basal and a ceiling. And a basal age is the age at which, from that point below, they could get every single item correct. And the ceiling would be the age at which um, they would get all of the items wrong. So, let's say you were testing a kid who was 10 years old, you might start him out at about an 8-year level and make sure they could get all of those items right before you went on. So, the test was rather laborious. It took a long time and so on. But, the whole purpose of it was this. And let me pull up my whiteboard here for you and um, create something. So what Simon and Binet were attempting to do was to identify a child's mental level. Uh, let's abbreviate that ML, their mental level, which they recognize might be different from their what we will call the chronological age. So you might have a kid whose chronological age is he's 10 years and 6 months old, let's say. But when you gave him all of the items on the Simon Binet intelligence scale, it might turn out that his total Mental level is more like someone who is, let's say, 8 years old. And so, the recommendation was then, well, rather than try and teach this 10-year-old the way you would teach most 10-year-olds, it might be better to teach them the kinds of tasks and assignments and so on that you would give to an 8-year-old. By the same recognition, maybe this 10-year-old's mental level is more like that of somebody who's 12 or 13. Well, it would make more sense to instruct the child the way you would instruct a child of that age. In other words, give them more challenging things, that this is a child who's capable of thinking at a higher level. So that was the purpose of the Simon Binet intelligence scale. Well, we had the same kind of problems in the United States. There were kids that didn't seem to be benefiting from a traditional approach to education in the United States. And so in 1908, Henry Goddard translated the Simon Binet intelligence scale into English, and it was administered to kids in the United States. Well, guess what? Kids in the United States didn't do very well on the Simon Binet intelligence scale. They scored significantly lower than French children did. Why do you suppose that was? Well, this was an early indication of what we call cultural bias. There are lots of terms and phrases, expressions, etc., in French that people in the United States just don't use. They weren't familiar with. In fact, I'll never forget when I first moved from Wisconsin to Texas to go to college. I encountered people who didn't necessarily speak the same vocabulary that I did, even though we were all speaking English. I remember being on campus and asking somebody where a bubbler was. And they said, "A what?" I said, "A bubbler." "What's a bubbler?" They had no idea what a bubbler was. Well, I discovered that in Texas, they call bubblers water fountains. In Wisconsin, we call them bubblers. The original water fountains were made in Wisconsin and they were called bubblers, and people just called them that. By the same token, some guys in the dorm were talking about the commode, and I said, "What's a commode?" And they were like, "You don't know what a commode is?" "No." "Well, don't you have commodes in Wisconsin?" Not that I'm aware of." Well, it's a toilet. I never heard anybody growing up call a toilet a commode. So, this is just moving about 1,500 and miles or so from Wisconsin straight down to Texas. So, imagine taking a test that was put together in French to test kids in France and then just translating it into English and bringing it over here. Of course, people didn't score very well on it. And so in 1916, Louis Terman, who was a professor at Stanford University, uh, renormed, retranslated, if you will, reworded the Simon Binet intelligence scale into English the way it's would be understood in America. And he renamed the test the Stanford Binet intelligence scale. Okay. Well, this really big issue of intelligence, though, really got heated up in 1912. That was the year the Titanic sank. when William Stern, who was a German psychologist, uh, came up with his famous formula. And what William Stern did was he said, uh, instead of the mental level, he changed this to a mental age. We're going to call that an MA. And Stern said if you divide someone's mental age by their chronological age, and then in order to get rid of the fraction, multiply it by 100, and you will get their intelligence quotient or IQ. This is where it really gets heated up. So, let's say you've got a kid and he's 10 years old. That's his chronological age. And if you gave him all the tests in the Stanford Binet Intelligence Scale, and when you added it all up, his mental age was also 10. Well, 10 times 10 times 100 equals 100 IQ. And that is what we call average. If you have average intelligence, then your mental age ought to be equivalent to your chronological age. Okay? But what if you've got somebody who's, their mental age is more like that of an 11-year-old and they're 10 years old? Well, then their IQ becomes, 110, and that's above average. And if it's a 12-year-old, their IQ would be 120. Well, that's in the superior range. But if they're 10 years old, but their mental age is let's say 7, well, now uh, you're ending up with an IQ of more like 70. And, that's borderline deficient. So, when we started classifying people, that's when this controversy really got heated up big time. And let me show you something that's pathetically humorous. Um, and this is what I'm about to show you is I IQ classification chart that was actually in the back of an intelligence kit that I was using when I began my career in Austin in 1977. And let me show you this. This is something else. Take a look at this. Um, Hold on. I'm having some technical issues here. Well, a real problem with that old formula is once you get into your adult years, then, well, let's just say, How old is the typical college graduate, for example? You know, in the formula, let's say your chronological age, you're a little bit older student, and your chronological age, let's say, is um, my whiteboard doesn't want to write here. Hold on. Okay, let's say your chronological age is 45, and then the typical college graduate is 22. Well, you would end up with an IQ that just isn't appropriate. And so, the Stanford Binet just doesn't work after the age of 18. In fact, consequently, when we used to figure IQs this way, uh, the maximum chronological age that you could get would be 18. And so, it's one way of becoming forever 18. Well, if the Stanford Binet issue wasn't bad enough, things got even more technical and upsetting. In 1939, when David Wechsler published the Wechsler Intelligence Scale, and let me pull that up for you in a second here. So, Wechsler said that intelligence follows a normal probability curve. And so statistically, he figured out uh, IQs, if you will, along a normal probability curve. And according to Wechsler, and if you look at this chart, I just love this chart. This shows you just how goofy I am. I think this chart is the greatest drawing ever. I used to have one in my office. But if you look down here at the bottom of the chart where it says deviation IQs, notice 100. And again, if you had average intelligence, then your mental age and your chronological age ought to be the same. And so that would put you right smack here in the middle of a normal distribution of intelligence in the general population, right here. So, according to David Wechsler, a total of 68.26% of us will score an IQ somewhere between 85, which is negative one standard deviation below the mean, and plus one standard deviation above the mean, which is 115. So, in other words, 68.26% of us have an IQ somewhere between 85 and 115, somewhere between slightly below average and slightly above average. That's where most of us are going to fall. A standard deviation in the Wechsler scales, by the way, happens to be 15 points. And you say, well, what is a standard deviation anyway? Well, this is a statistical concept that I'm going to share with you right now. And this is how a standard deviation is figured. And I thought some of you might be able to relate a little bit more to this definition if we use something like football example. And this example is that of a punter. And this is a punter for a team kicked 4 kicks. And if you add up all, the first kick went 36 yards. The second kick went 38 yards. Another kick went 41 yards. And another one went 45 yards. So if you add all those numbers up and then you divide it by 4, you get a mean or an average kick of 40 yards. And so, when you're watching a football game on TV or listening to one on the radio, the team you're following might not make it on third down, and so it's fourth down, and they bring in the punter, and the announcer says, the punter for our team is averaging 40 yards per kick. Okay. Does that mean he's going to kick it 40 yards? Well, he might, but he might kick it 45 yards, or he might only kick it 36 yards. And so the way you figured a standard deviation is like this. First, you figure out how far is each of these punts from the mean, in other words, from the average. And so a 36 is minus 4 yards from that average of 40. And a 38 is minus 2. A 41 is plus 1. And a 45 is plus 5. And then when you square all of those things, you end up with this formula. So a standard deviation equals the square root of the sum of the deviations squared divided by the number of scores. And so this equals, in this example, the square root of 46 divided by 4, which is 3.4 yards. So what it means basically is this. If his average is 40, well, a standard deviation for this guy is 3.4 yards. So he might kick it 43.4 yards. Or he might kick it 40 yards minus 3.4 yards. That's basically what a standard deviation is. It's the sum of the deviation squared divided by the number of scores, and that gives you the answer, so to speak. So if we go back to this way David Wechsler figured IQ scores, again, the vast majority of us will score somewhere between +1 and -1 standard deviation. Again, a standard deviation on the Wechsler scales is 15 points. So the vast majority of us is going to score somewhere between 85 and 115. Only 13.5% of us will score somewhere between 115 and 130. In other words, somewhere between above average and very superior. And only 2% of us would score higher than 130. Not very many people in here. By the same token, about 13.5% of the population will score somewhere between -1 and -2 standard deviations below the mean. In other words, 13.5% of the population will score somewhere between 85 and 70. On the other hand, only about a little over 2% of the population is what today we would call intellectually disabled. So most of us are average. So if I gave you an intelligence test, where do you think you would end up? How many of you would be glad to discover that you're in the average range here, somewhere between 85 and 115? Would you be okay with that? How many of you think you would score above average? Somewhere between above average and superior. How many of you think you would score in the very superior range? See, the problem with this is most of us are average, and people don't want to be known as average. You know, what if a friend of yours was fixing you up for a blind date, and the blind date said, well, yeah, well, you know what is he like or what is she like? And your friend said, oh, uh, he's an average guy. He's kind of average looking, kind of got an average personality, you know. Oh, worse yet, yeah, no, none of us want to be average. What if you asked me to write a letter of recommendation for you so that you could transfer to some four-year university or get in some competitive program in the School of Nursing or something like that? And I said, sure, I'll write you a letter of recommendation. And then I said, of all the students I've taught in the last 30 years, this person is a good average student. They're as average as they can get. Would you want me to say that? No, of course not. You want me to say, oh, of all the students I've taught in the last 30 years, this person is, you know, they're in the top 2% of all the ones I've ever had in class. Or they're way above average. There's nothing average about this student. That's what you want me to say, don't you? But see, the problem with that is if we're all above average or if we're all superior, then that gets distributed normally in the population, and then above average or superior becomes average. Uh, and this is a real problem right now, quite frankly, with grades. There's a serious problem in college with grade inflation. Everybody's making A's or nobody's making below a B. Well, then how do you stand out from other people? You see, I would ask the question, how many of you would like to make a C in this course? How many of you like to make a B? How many of you'd like to make an A? Well, a C is average. That means on the normal probability curve, you're right in here. A C is average. It means you did all the work and you did fine. A B means you did significantly better than, uh, you're in the top 13%. You did better than about 85% of your classmates. And an A in the course would basically mean you should be in the Intro to Psych Hall of Fame. There ought to be a special exhibit in a museum for you because you're better than everybody. So this whole concept is controversial, isn't it? Nobody wants to be average. None of you want to be average. If people ask you, hey, Professor Grangaard, what's he like as an instructor? He's kind of average. I don't want you to say that about me. I want you to say, oh, it's the best online course ever. That's what I want you to say. So that's why the whole concept of intelligence is so controversial. Let's take this a step further. Have you ever had an IQ test? Well, any of you ever take a test called the SAT, the Scholastic Aptitude Test? It is a type of intelligence test. And the SAT, you can see your scores on this wonderful chart. And they're listed right here as CEEB scores. In other words, College Board scores. And on the SAT, the mean is 500 with a standard deviation of 100. Okay. Now, that's for the verbal or the math. I'm not talking about adding it together. The verbal and the math is 500. Okay. So if you made a 500, let's say on the verbal part of the SAT, that's the equivalent of a 100 IQ. If you made a 500 on the math, that would be the equivalent of a 100 IQ. Let's say you made a 600 and by the way, a perfect score on either the verbal or the math part would be an 800. Okay. So let's say you made a 600 in the verbal, then you would have an IQ of, oops, sorry, 115. Yeah, if you made a perfect score on the SAT, an 800, then that's the equivalent to an IQ of 145. By the way, the highest IQ you can get on the Wechsler scales is a 160. And about the highest that in the Stanford Binet now is figured the same way as the Wechsler scales, and about the highest score you can get on that is a 190. So when you read these stories about somebody who has a 230 IQ, it's a lie. There's no test that measures that high. And yet, you see these little stories on social media or in the press about somebody who's got a 241 IQ. No, they don't. It's a flat out made up story. It's a flat out lie. You can't have an IQ like that. There's no test that measures that high. Okay. Well, let me tell you something else about the SAT, though, while we're at it. The SAT has a reliability, and we'll talk about those terms in a minute. fact, let's let's talk about it right now. Let me show you a whiteboard again. Hold on. I've discovered there's different, want you to introduce you to a couple of terms, and they include reliability and validity. And reliability has to do with the consistency of the test. And there are all sorts of different types of reliabilities out there, but the two we're going to concern ourselves with are uh, test, retest, and alternate forms. Now, what I would tell you about the SAT's reliability, and that is it is extremely high. In fact, it is what we call 0.90. In fact, for some of the subtests, it's even higher than that. It's more like 0.92. Basically, what this means is if you retook the SAT 10 times, 9 times out of 10, you will get virtually the exact same score you got the previous time. Why? Because the SAT has excellent test, retest reliability. In other words, it's consistent. So let's say you retake the SAT because you wanted to improve your score. Did you get the same exact test that you had previously? Well, of course not. And the reason for that is there are alternate forms of the same test. I don't know how many different forms of the SAT there are. Maybe there's 20. It wouldn't be good if the people who took the test in October got the hard version and the ones that took the test in November got an easier version. Then the test wouldn't have good alternative forms reliability. That wouldn't be fair. So a test that is reliable in terms of alternate forms and test retest, it shouldn't matter which form you get or how many times you take the test. According to the statistics associated with the Scholastic Aptitude Test, the reliability coefficient is at least 0.90. Again, that means if you took the test 10 times, 9 times out of 10, you're going to score. Here's another term for you. This term is called the standard error of measure. And on the SAT, the standard error measure are a plus or minus up to 31 points. And so if we go back to our chart where the mean of the SAT is 500, Uh, and because it has a standard error measure of plus or minus 31 points, if you retook the test 9 times out of 10, you might score as high as 531, or you might score as low as 469, 9 times out of 10. Let's go back to our standard probability scale chart. Okay, so let's say you took the SAT, and on the reading, the first time you took it, um, you scored 469, and you retook it a couple of months later, and you made 584. Wow, over 100 points more. You went from 469 to 584. Well, let's look at what happened to you on this scale. You went from 469, which is right about here, and you went from there to 584, which is right about here. Wow, so you went from average to average. Isn't that impressive? See how annoying all this stuff is? Uh, it's hard to beat the statistics on this test. Um, and to show you just how consistent it is, I've got to share this story with you because this is especially amazing. And there was this article I read in the Wall Street Journal, and it was about this high school student who was getting ready to take the SAT, and he was really hyped up and nervous and all of that. And his mother's attitude was, "Oh, it's really no big deal." And the young man said, "Well, it's easy to you for you to say you took the test a million years ago, and if you took it today, you would have a really hard time." And his mom said, "Okay, I'll take you up on the challenge of that." And so 42 years after she took the SAT, when she was in high school, she took it again with her son. And these are some interesting things. In 1967, his mother got a verbal score of 800, which is a perfect score, very superior to the 99.9 percentile. And she got a math score in 1967 of 640. In 2009, she retook the test with her son and she got a verbal score of 800. And she dropped a little on the math. She got a 600 on the math when she retook it. But that shows you just how consistent the SAT is. Is it consistent? And how? 0.90 reliability coefficient. 9 times out of 10, you're going to get exactly what you got the last time. At least you're going to score within one standard error measure of what you got last time. And she got a little lower than one standard error measure on the math, 42 years after she took it the first time. So the SAT is very reliable, but a bigger question is it valid? And, validity is, basically, does the test measure what it says it measures? And there's different types of validity, but the main one we're concerning ourselves with here today is called predictive, predictive validity. What's the purpose of the SAT? To predict how well you'll do in college. Does it do that very well? We probably all know people who didn't do very well on the SAT, but seem to be doing just fine in college. On the other hand, we may know people who did terrific on the SAT and aren't doing so well in college. I think of a former client I had. I ran into him one day on the Rio Grande campus. He was a former private practice client of mine. I was surprised to see him at the Rio Grande campus. I say, "What are you doing here? I thought you were going to UT." He was like, "Yeah, I kind of flunked out." I said, "What? Wait, hold on." This guy had graduated valedictorian in his high school class in Austin. He had been president of the student council. And he played in the school orchestra, an instrument. Um, he had made a perfect score on the SAT. He had won an all expense paid scholarship to the University of Texas. I'm talking room, board, books, tuition, the works. And he ended up after a semester over at ACC trying to improve his grades and get back into UT. Ah, but he had a top of the line SAT scores. So, did it have predictive validity for this student? Did it predict how well he would do in school? No, not at all. It didn't figure in all the parties he went to and skipping class and all that other kind of stuff. So here's what I want to tell you, and here's something I want you to write down. If you don't write anything else down in your notes, you need to write this. Are you ready? Here it is. A test can be reliable without being valid. A test can be reliable without being valid. Is the SAT reliable and how? 0.90. 9 times out of 10, if you retake it, it doesn't matter what form you get, you're going to score within one standard error measure of what you got the last time. It's very reliable. Is it valid? Well, it certainly wasn't for this guy. But a test cannot be valid without being reliable. A test can be reliable without being valid, but a test cannot be valid without being reliable. In other words, if every time you take the test, you get a different score, sometimes you score high, sometimes you score low, sometimes you score in the middle. Well, then what is your actual ability level? We can't get a valid look at your ability level if you're all over the place. So in order for the test to be valid, it's got to be reliable. You ought to be scoring consistently about the same. So this is what I want you to know. Know this for the test. A test can be reliable without being valid, but a test cannot be valid without being reliable. Okay, so we've been talking about measuring intelligence, but let's get back to the foundation of measuring intelligence, and that is, what are some theories about intelligence anyway? And the first one I want to mention is that by Charles Spearman, who came up with what he called his G factor theory of intelligence. According to Spearman, there is a general factor that underlies all of intelligence that affects everything else. And, Spearman's G factor is probably that of language. In fact, the single best measure we have of intelligence is vocabulary. The broader and more precise an individual's vocabulary is, generally, the higher they will score on traditional intelligence tests. The G factor of intelligence is probably language. Louis Thurstone came up with his 7 primary mental abilities model of intelligence. And Thurstone says that intelligence primarily consists of verbal comprehension, numerical ability, spatial relations, perceptual speed, word fluency, memory, and reasoning. What I would tell you is Wechsler's intelligence scales are based primarily on Thurstone's 7 primary mental abilities. For example, there are questions involve verbal comprehension. For example, what is the thing to do if while in the movies you're the first person to see smoke and fire? Uh, you know, Notify the management, tell an usher. You don't yell fire. That would be a zero answer. It would cause a panic. Uh, Verbal comprehension kinds of questions. A numerical ability. How well can you work math problems in your head with speed and accuracy? That's another thing about intelligence tests like the Wechsler scales is some of the subtests are timed with a stopwatch. You see people who have higher IQs not only get answers to things like math problems that they're working in their heads correct, but they do it faster than the rest of us. They process things faster. Spatial relations has to do with taking blocks that have designs on them and making them look like a design on a picture that you're shown. Putting jigsaw puzzles together without having a picture to take a look at. Uh, Perceptual speed, word fluency, and defining words. How concisely and accurately can you define what different words are? Uh, the interesting example on the children's Wechsler test is the word donkey. What is a donkey? Uh, if the kid says a jackass, that's a 2 point answer. If they say an ass, it's a 2 point answer. If they say an animal, that's a 2 point answer. But if they say a mule, that's only worth 1 point because actually a donkey and a mule aren't exactly the same thing. You know, if the kid says they got 4 legs, well, that's a 0. That's not defining what a donkey is precisely and accurately. And then memory kinds of things. We saw a lot of this when we were talking about memory and the Wechsler memory scales, you know, rattling off a series of numbers and having the person repeat them back to you, and then after a while repeat them backwards and that sort of thing. Um, Memory is a part of intelligence according to Thurstone. And then reasoning. These are things like how are a table and a chair alike? Well, they're both furniture. That would be a good 2 point answer. Uh, again, if they said, well, they have 4 legs, well, that's not a good answer. I mean, there's some pieces of furniture that don't have 4 legs. So there are animals that have 4 legs. So, how are a table and a chair alike? It's reasoning. How are a fly and a tree alike? They're both living things. If you say, oh, they're both outside, well, hopefully, but that would be a 0. So how do you think you do on an intelligence test? Would you score in the average range? Would you be in the top 15%? Would you be in the top 2%? Uh, Especially when you did the math problems quickly and accurately. Uh, Thurstone's 7 primary mental abilities. Um, let's take a look at another one. And this time I want to show you J.P. Guilford's model of intelligence that's really especially good, I think. So, you say, well, intelligence isn't just one factor. You say it's a general factor. It's not just 7 things. There are all kinds of components to intelligence. And, so Guilford came up with a 150 factor model that looks like this. And let's see if I can make it a little bit bigger for you. Yeah, how's that? Um, and eventually I think he even got higher than 150 factors. I think he got up to about 180 eventually. But Guilford says intelligence is made up of all kinds of things. There are visual factors, there are auditory factors, there are symbolic factors, there are semantic factors, there are behavioral factors. And it involves cognition, it involves memory, it involves thinking divergently and convergently. It involves evaluating things. And it involves units of measurement and classes and relationships and systems and transformations and implications. Excuse me. Intelligence isn't just seven things or one thing, it's all kinds of things. It's a great model, don't you think? The big problem with it is this. How do you come up with an intelligence test that measures 150 or more factors? I mean, you can't just have one question for each factor. That certainly wouldn't produce a valid test. Although, in general, if you want to increase something's validity, it's good to make it longer. But on the Wechsler scales, for example, which is based on Thurstone's seven primary factors, there's maybe 30 items for each section of the test. Well, if you had 30 items for 150 factors, you'd be testing the individual all week. Maybe all month. I don't know. Nobody could sit through a test that long. And so this is a real problem to measure all the factors that would be necessary in this model. My own personal favorite model, and I'll show you that one right now, and that is Robert Sternberg's triarchic theory of intelligence. And Sternberg says there's three main components. So you might look at it more of as if it were three distinct types of intelligence. And he calls these componential intelligence, experiential intelligence, and contextual intelligence. I met Robert Sternberg a number of years ago at a meeting, and I wish you could get to know him. He is an absolutely delightful individual. And I really like his triarchic theory. By the way, he also has a triarchic theory for love that's even better than this one. That's for a different course. But componential intelligence or analytical ability is the ability to think abstractly to process information effectively. According to Sternberg, what traditional intelligence tests like the Stanford-Binet or the Wechsler Intelligence Scale, the Wechsler Adult Intelligence Scale or the Wechsler Intelligence Scale for children, what they measure is basically componential intelligence, analytical ability. They don't really measure anything else. Experiential intelligence is creative ability, your ability to formulate new ideas, to combine seemingly unrelated facts or information. How many of you went to a school where you had classes for the gifted and talented? And how did you get into those classes? I used to do some testing for the Lake Travis Independent School District. And you know how they decided who got into their classes for the creative and superior students? We gave them a Wechsler Scales IQ test. And they had to score 100 and I think it was 120 or higher in the Eanes School District they made the kids score 130 or higher. They had to be in this very superior range. And then they got into classes for gifted and talented. Problem, classes for gifted and talented are to zero in on these people with creative ability, and yet the tests they're giving to qualify them for the classes only measure componential intelligence. Excuse me, I'm getting all worked up about it. That's how distorted school districts tend to have views of what intelligence and creativity and talent is really all about. Then there's contextual intelligence or practical ability, according to Sternberg. And this includes common sense, street smarts, the ability to adapt to changing environmental conditions and to shape the environment so as to maximize one's strengths and compensate for one's weaknesses. You know, these are the guys that can take a lawnmower apart and put it back together again. Now, how many people who would score high on the Wechsler scales wouldn't have a clue how to get their lawnmower to work if it wouldn't start? Or have no ability to be creative and write lyrics to songs and things like that. These are three different kinds of intelligence, and some people might have one and not the other. I want you to watch some links I have in this section to scenes from a movie that is actually a true story. It's the story of Apollo 13. If you're as old as me, you were around when Apollo 13 actually happened, and you saw the real people in action, not Tom Hanks. But it's a great movie, and I want you to watch the scenes that I have links to because there are going to be questions on the test about this. So what happened in Apollo 13 and why I tie this into Sternberg's triarchic theory of intelligence? Well, Apollo 11 had gone to the moon, and here's one small step for man, one giant leap for mankind. Neil Armstrong and Buzz Aldrin followed him out. They did their moonwalks and all of that. They came back, and then Apollo 12 went. And then by the time Apollo 13 went, hardly anybody was even paying attention anymore. It's like, it's just routine stuff. They're going to the moon again. So they're on their way to the moon, and they're getting ready to settle in for the night. And the guys down in Houston and in the command center said, well, we're going to do a little housekeeping for the night. I want you to flip a few switches on and off and make sure everything's working fine. They flipped this one switch and there was an explosion. And now the question wasn't, were they going to be able to land on the moon and get back safely, but were they going to be able to get back safely, period. The ship suddenly is disabled. And if that wasn't bad enough, the air was becoming unbreathable. And they needed to figure out a way to create uh, a new filtration system to filter out the carbon dioxide that was accumulating inside the spacecraft. And I love this scene in the movies. The guy who's the head of uh, this operation for NASA walks into this conference room with a bunch of engineers with a box full of junk, and he dumps the box out on the table and he says, in front of you is one of everything they have on board that spaceship. You have almost no time at all to figure out how to turn these random parts. I'm talking duct tape and plastic bags and things like that. You've got almost no time at all to turn this stuff into an air filtration system, plus come up with the procedures for us to send up to them. That basically you have on the table in front of you one of everything they have on board that ship that they could possibly turn this into an air filtration system and save themselves, or they're going to die of carbon dioxide poisoning. So were they able to do it? Well, miraculously, yes. Well, who were these people? Well, it was a room full of NASA engineers. Okay. Did they have confidential intelligence? You better believe it. Probably every guy in that room had an IQ of 130 or higher. We're talking PhDs in engineering here. Okay. But did they also have creative ability? You're going to take this junk and create it, and practical ability, street smarts. You're going to take all this stuff and put it together and put together a list of procedures so that we can radio it up to these guys and they can do what you tell them to do and hook it all up and save their lives by creating this air filtration system. And did they do it? Well, watch the video. I think it's an impressive example of Sternberg's triarchic theory of intelligence. Okay. All right. Well, then there's Gardner's eight intelligences theory. Uh, you know, uh, Howard Gardner would say there, there are all kinds of specialized intelligences, if you will. Maybe you can identify one or more that you have. There are people with linguistic ability. They're just really good at language. How many of you speak more than one language fluently? More than two, more than three. I had a student in class that spoke like seven languages. English, Spanish, Portuguese, French. She was studying Japanese while she was in my class. Amazing. For some people, other languages come easy. For some of the rest of us, if you've ever tried to learn another language, it was a real challenge for you. There are some people with logical, mathematical uh, aptitude, if you will. How many of you are really whizzes at math? Comes easy for you. How many of the rest of us find ourselves flipping through the ACC catalog, looking at different majors and then asking the question, how many math courses do you have to major in this? Only one? Oh, I'm going to major in that. Some people, math just comes easy for. Other people, it's a real struggle. There are people with musical aptitude. How many of you have musical aptitude? Do you play an instrument or maybe a couple of instruments? Are you a singer? My daughter's got musical aptitude. She's got a couple of degrees in music and she's employed as a music therapist. She plays all kinds of instruments, guitar, piano, drums, you name it. And she sings. I play the stereo. Music aptitude. There's some people who have spatial aptitude, spatial intelligence, if you will. These are artists, sculptors, people like that. How many of you are really good at drawing and painting and things like that? And some of the rest of us got all we can do to draw a stick figure. And yet there are people who do cartooning and all sorts of fun things. There's some people who have bodily kinesthetic aptitude. Are any of you kind of natural athletes? You're just really good at sports or good at dancing, things like that. You've got bodily kinesthetic aptitude. I think of Tiger Woods. Yeah, you can rest assured he did a whole lot of practicing golf. But when he was like 3 years old, I saw a video of him. They had him out on a major street in downtown New York, teeing off, hitting golf balls down the street, straight as an arrow. He was 3 years old. Uh, so, yeah, he's worked hard at it. He's done a whole lot of practicing, but he also has bodily kinesthetic aptitude, and that helps. Or how many of you have intrapersonal intelligence? You're very well adjusted emotionally. You don't get upset easily. Or do you have a high level of interpersonal aptitude? You're good at smoothing out conflicts between other people. You're a good intermediary, if you will. Uh, you're good at mediation. These two things, Daniel Goleman has more specific terms for. He calls intrapersonal aptitude uh, I was going to pull some up here for you. Hold on there. Goleman calls interpersonal aptitude in emotional intelligence, and he calls interpersonal aptitude social intelligence. Goleman would say your EQ, your emotional intelligence is a whole lot more important than your IQ. And your social intelligence or your SQ is more important than your IQ. Just how well emotionally adjusted you are and just how well you interact with other people. That's what's really important, not your score on an intelligence test. In fact, I'd like to end this with sharing a rather humorous cartoon with you. Um, if I can find it. This is it. I just love this. This is basically what good the uh, SAT is. This guy died, and on his tombstone, here lies Frederick Jones, verbal 680 and math 720. Who cares? What's more important is your emotional intelligence level and your social intelligence level. Think about that in the days ahead.